Let's look at this problem 2 that was in chapter 8. It turns out that the biggest difference between momentum and energy is that momentum is a vector. And so with every momentum problem, you're going to need to keep the direction straight. Whether you do that by drawing the vectors or whether you set up a coordinate system and do it with your plus and minus sign, you have to be careful with direction. In this case, we have a ball that is approaching a wall at 15 meters per second. The ball has a mass of 0.2 kilograms. It bounces and leaves the wall at 10 meters per second. Now, this is a momentum problem, and so what I'm going to use here is this impulse momentum equation. Now, just like I did with the energy equation, I can subtract the initial momentum from both sides, and I can write this as impulse is equal to a change in momentum. And that's going to be force average times delta t is equal to the change in momentum. Now, the first thing we're looking for is the change in momentum. Well, if I start with a momentum that's going to the left, that's 3 kilograms times meter per second, let's pause for a moment. We took the units Newton meter and we honored a dead professor. We called that a joule. What do we call a kilogram meter per second? It's never been named. So we're going to name it the Francis. I've got enough students that I figure this is going to catch on. If all of you just stick with this story, I'm going to be famous. Plural, of course, is Franci. So I've got 3 Franci to the left, and afterwards I have 2 Franci to the right. Well, the difference between 3 and 2 is not 1, because it's not really 3 and 2. It's 3 to the left, it's 2 to the right. And the difference there is 5. The change, or difference, is what I have to add, there's the plus sign, to this initial momentum to bring that momentum all the way back to 0 and out the other side. Okay? Now, if we wanted to do that with mathematics, we would set up a coordinate system where if we call the right positive x and the left negative x, well then our change in momentum would be final minus initial. And in this coordinate system, my final momentum is after the bounce. And that's going to be to the right, or the positive x direction, plus 2 Franci. And then I subtract off the initial momentum, which is to the left, so it would be a negative 3 Franci. And the minus minus is adding, so that's going to be a positive 5 Franci. Now I can find the average force just by dividing that change in momentum by the time that was involved, the 0.02 seconds. And what I'm going to get is 250 newtons, and it's a positive 250 newtons in that coordinate system, meaning it's to the right. And that's what you'd expect the wall to do, is push to the right on the ball. Are there questions about that problem?